Okay, let's go ahead and begin this homework exercise with homework exercise number 13 from section 8.4. Exercise 13 states, determine the effective annual yield for each investment and select a better investment. The better investment will be the one with the higher annual yield because that will produce more money. First one's 4.5% compounded semi-annually. Well, the yield formula is 1 plus the rate divided by n raised to the n power minus 1. So 4.5 compounded semi-annually is going to be 1 plus the rate is a decimal, move it over 2 places, 0.045, divided by 2, semi-annually, n equals 2, raise to the second power, get out of the exponent, and subtract 1, and then move it over 2 places to get the decimal. So we'll have, so if we do it on our calculator, put in the parentheses first, left paren, 1 plus 0.045 divided by 2, because it's semi-annually, raised to the second power, then get out of the exponent with the right arrow key, subtract 1, and move it over 2 places, multiply by 100, so 4.55 will be rounded to 2 decimal places, all right? The 0 follows the second 5, so it's going to be 4.55. Okay, now the effective annual yield compounded daily. Okay, so daily, it's going to be the yield is 1, left paren 1 plus the rate. This time the rate is 0.044 divided by 360 because daily we're assuming 360 days in a year. So you raise it to the 360th power, get out of the exponent, and subtract 1. So again, we'll put that into the calculator to evaluate it. Left paren 1 plus 0.044 divided by 360. Right paren, up arrow, raise to the 360th power. Then a right arrow to get out of the exponent, subtract 1, and we get, move it over 2 places to get a percent, 4.497. So again, so we would 4.497, we round up, so the 9 would become a 0, and then we'd have to put the 4 or 5, so it would be actually 4.50%. So compounded daily will be 4.50. All right, the effective annual yield for the semi is 4.55, which is higher than the effective annual yield for the daily. So then the semi-annually will be the one that produces the, that will be the better investment because it'll produce more money. All right, very good. All right, number 14. At the time of her grandson's birth, the grandmother deposits $12,000 in an account that pays 7% compounded monthly. What will be the value of the account at the child's 21st birthday, assuming no other deposits or withdrawals are made during this period? Okay, so we want the future amount. Original principal times 1 plus r over n raised to the n times t power. The original investment is $12,000. Okay, 1 plus the rate pays 7%, 0.07 compounded monthly, so we're going to divide by 12, and the exponent is n, which is 12, representing 12 months in a year, times the number of years, 21st birthday, so it will be 21 years. Okay, so there's the correct values for the formula. We'll substitute them into the calculator and get the value. So again, the principal was 12,000, left paren, 1 plus 0.07 divided by 12 exponent raised to the 12 times 21st power, $51,968.39, rounded to the nearest dollar to the left of the decimal. So we will have 51,968.39. There's a 3, so we would just keep it at $51,968 to the nearest dollar, which is to the left of the decimal. All right, let's go ahead and put that in. Very good. We're going to stop this session here. If you have any questions, send me an email at tswierzz, tswierzz@hodges.edu, or call me at 239-938-7805. Thank you.